Now, just before I start the next exercise, let's have a little recap of what we've achieved so far. So you've learned how to differentiate a function where you've got terms of x to a given power. You've learned that when a function is a little bit more complicated and in a position or such that we would describe it as a function of a function, then you know that you have to use the function of function rule. We saw that when the function that you are going to differentiate is the product of two functions, then again you must follow the product rule. So we're moving on to having a look at the quotient rule. And it, I would have to say, is a little bit easier to recognise. And we now have a quotient, which is a fraction, so one thing divided by another, which if it was written as f of x on g of x, for example, x cubed minus 5x all over x squared plus 2. That would clearly be where f of x was the numerator and g of x was the denominator. Now, you could replace this u and v, f of x and g of x with u and v, like we have previously for the product rule. And like I started off saying, I think it's a little bit easier to recognise this situation because of the fraction, really. You have seen fractions before though, and you were able to differentiate them because you were able to simplify them. And even now, you do have an option as for rearranging this fraction, and I'll just pause the video and write this up and come back and talk about it. If we were to use our understanding of dividing by x squared plus 2 and take this x squared plus 2 out of the denominator, assign it the negative power, we considered it alongside our numerator. So that function, overall function made up of two little functions, could sit like this, and you probably recognise that you could go back and actually use the product rule from before. So many questions now might actually even direct you to use the quotient rule just because they're wanting to test that you can use the quotient rule. So it's another reason why it's sometimes easier, because you're given the instruction to use it. So what is the function rule? So if you've got your u over v, then y dash, your derivative is v, that's definitely a v, u dash minus u v dash on v squared. HSC markers speak a lot about students getting lost in the algebra from here on, and I guess the marks are given for not getting lost actually and getting to the correct answer, because that formula also appears on the formula sheet, reference sheet. So if we go here to the reference sheet, just try and move. That should be right now. If it's actually here, if y is equal to u on v, then dy dx is v, your denominator. So you must start with the denominator. Du dx, we just write as u dash, minus u dv dx all over v squared. Now, after you've found your expression for your gradient, your derivative, just always check that it is possible that your derivative may have a point of discontinuity. It definitely will have a denominator, and the denominator of the derivative was the denominator of the function squared. You can see that. So this is your derivative, it's your v squared. Just be careful that there will be a possible x value where neither the function nor the derivative will exist. So if we think about this one, we know that 2x minus 1 cannot equal 0, so 2x cannot equal 1, so x cannot equal a half. Just be aware of that, and that will apply to both the function and the derivative. So I must say I have never seen a question where you've been asked to find the gradient where x, for example, in this case, where x is equal to a half. And I'm sure that if you tried to put x is equal to a half into the expression that you've created, then you will come across the 0 in the denominator. I guess a question could say, what happens to the gradient at x is a half? And you would be expected to say the gradient is undefined, the function is undefined, the gradient is undefined.